Well, hey, good afternoon, everybody. Happy last day of the seminars here. Real quick, my name is Drew. I'm one of the co-hosts of the Experimental Brewing Podcast, and I'll be your moderator here for this particular session at the Women's International Beer Summit. And today we are going to be talking to Anne Flesch about yeast. Everybody's favorite ingredient, I think. Hopefully, because otherwise it's just sugar water. So. Don't forget, if you have any technical problems, there's a big green tech help button down there in the bottom. Please go click on that because that will help you get your problems solved. We will also include a copy of the presentation, obviously online after all this is done. And we will have time for questions, so make sure you put your questions in the Ask a Question button down below. And also go in and look and, upvote the questions you want to see answered. So without further ado, Anne.
Thank you so much. Thank you for the introduction. Let me start with sharing my screen that I didn't want to start too early on. Wouldn't take all the space. Here we go. I'm going to go in slide mode. Here we go. All good? Can you see well?
All good.
All right. So, hello, everyone. My name is Anne Flesch, and I work for Fermentis. I'm the regional sales manager for Western North America. I'm based in Sacramento. I'm very happy to talk to you today. And today I will talk to you about how to choose a yeast strain for your beer, but also for your cider. When I talked with Melissa, getting ready for the conference, she said, cider is, I would like you to include something, and we definitely have interesting data on there. So I'll talk about cider too. All right. Now, of course, my computer doesn't want to move to the next slide. I'm sorry about that.
It's not a presentation until we have at least one technical difficulty.
Of course. I guess I have to stop sharing. Let's start again. My apologies. All right. Let's start again. All right, can you see the next slide?
You're not, I'm not seeing your share yet.
Okay, so let's start again. I'm sorry, we get a little bit of time here. Boom, here's screen.
Don't worry, during the time of COVID, I think everybody's gotten used to the question of, can you see my screen?
I've done that many times though. Should be better by now. All right, can you see this slide here?
Yes, ma'am.
All right, so another thing that was important is before I start, going into yeast and talking about yeast, making sure that, we get to know each other. In case you don't know what Fermentis is, who am I, how did I get there, share a little bit of life stories that are also, I think, very interesting. And of course, the star of the show, some fascinating facts about yeast. So Fermentis, I try to make it a bit interactive here in case you don't know what Fermentis is. I wrote, we work for this world. So what does it mean? What world? The world of the fermented beverage, of course. So we provide fermentation solutions, mainly under the form of active dry yeast, fermentation aids, yeast-derived functional products. We now have bacteria, especially for brewers. For the beer industry, the winemakers, distillers, also cider, and any fermented beverage. Under the Fermentis brand, we also have some interesting other brands that I thought you might hear about. One of them is Fermentis Academy, which is both a program of research and development, but also of education. So we do have full days of seminars when the context allows, but now we also have a whole brand of online webinars for homebrewers, for brewers, for winemakers, distillers, and so on. And we post them also on our website. So anything that you might find interesting in my presentation, any subject, you might go deeper in these presentations. Actually, Fermentis is a business unit of a very large yeast producer, one of the largest yeast producers of the world, called L'USAF. So that's why it's called Fermentis by Lusaf. And it is a French-based company, but it is a global international player. The proof is that I'm here in Northern America with many years of experience. R&D centers. We are present in most of the countries in the world, and we have production sites everywhere in Europe, in the US, but most of our brewing and I would say Fermentis strains are produced in Europe and exported, for example, to the US in the case of the US. And here you have a wonderful picture of the Fermentis team at the Brow, I think, and that's the best part about working for Fermentis. I would say it's working with an incredible team of people coming from, brewing experience, winemaking experiences, distillers, very, very interesting and diverse backgrounds. All right, and now I am stuck again on this slide. That's not gonna go well. Why is it? I'm sorry about that. I don't know how I'm gonna have to do that if I have to restart my presentation every time.
Yeah, we might.
Let me start again.
All right.
All right. Sorry about that, everyone. All right. So facts about me here. Just very quickly, I'm the regional sales manager for Western North America, which means I get to travel and meet, home brewers, distillers, winemakers, and that's the best part about my job is meeting people from all around the world. I would say the most challenging part of my job is also the traveling in regular times, definitely not in coronavirus time. I do believe that fermentation is the most fascinating part about any beverage, whether it's wine or beer, because it does require both an artistic side and a good understanding of the science. And if you don't have both, it's going to be pretty hard to make a good beverage, I think. My education, I am a biosystem and food engineer. I have my degree from France. My experience, I've worked both in R&D in biofuels with microalgae, and then I'm also an enologist. I then moved to completely to wine production, both experience in France and the US, in Washington State. And that's how I got into Fermentis. I would say I now have a passion for all fermented beverage, but I say my true love still lies in wine. And also something I've developed is yeast jokes. So any good yeast jokes that you have, please send them my way. Just then lastly about me, I have a family here. You might hear them in the background, even though yeast might be considered my little kids too. I love swimming, biking, running. I love cooking, baking. And I've been in the US for 8 years. So, sum up with the 27 years in France, you might know my age by now. All right, enough about me. 12 facts that I think interesting about yeast now. I think the most interesting fact for me, learning and knowing about yeast is just this history of selection that we have with yeast through the centuries of making fermented beverages. We like yeast shepherds, and with time we have selected the ones that are the most interesting for us and the beverage we want to make. So I see us as these shepherds of the yeast. So what is yeast? It's a eukaryotic single-cell organism, part of the fungus kingdom. They go from 3 to 40 microns, and there is obviously a huge diversity of genera and species, even though we use a very small portion during the fermentation process of main beverages. There are 1,500 species identified, which only represent 1% of the fungal kingdom at this point that are known. Something that we'll talk about later, and I think it's very important when you choose a yeast, is to know that all the yeast that you can find, available for you as brewers, winemakers, or producers of ciders, cannot all utilize the same type of sugars or with the same affinity. So it's something that is very important when you select a yeast strain to know what this strain is going to be able to ferment and in what proportion. Something else that I think is always underrated is the impact of yeast on your the final flavor and aroma profile of your beverage. In wine, it was defined between 50 or 80% of the global flavor aroma was due to yeast-derived aroma. I'm pretty sure in beer, it's going to be almost higher than that in the range. So really depending on the beverage, but it's a crucial choice, of course. Each strain that you're going to choose is going to have its own fermentative aroma profile, and we'll talk a lot about this during this presentation. Something else of important is that you might know, of course, is fermentation parameters. Temperature, pitching rate, gravity can have a huge impact on fermentation and aromas, but some strains are going to react stronger in change of fermentation parameters than others. And the last thing is really have been talked about a lot in the past few years is that yeast interact a lot with the aromatic precursors in your beverage. So hops for beer, or if you grape or apple, and are enzymatically going to release some volatile compounds, and so that's why I selected these little balloons, really to make them volatile and completely affect the perception of these aromas in your beverage. So at Fermentis, we have active dry yeast. So I just wanted to put a few facts about active dry yeast. It is, one of the freshest form of yeast that you can really find on the market. When you think about it, we produce yeast, and immediately when it's produced at its optimal stage, we dry it to keep it dormant. So it's really, when you use it, it's at its freshest stage. So I know sometimes there is misconception there. It does have a very long shelf life of 3 to 4 years, where it stays really at this high quality, similar level. And also, we do have a certification called Easy to Use here. That pretty much means that you can now direct pitch all our active dry yeast without being worried that it would affect your fermentation or the beverage. So it's a certification on the yeast that guarantees that you can direct pitch them. And I said I love yeast jokes. I wanted to prove that. So why would you want to be friends with a yeast? And
why would you want to be friends with a yeast?
Yes. And the answer is because he's a fun guy. All right, that's it. I'm moving on from there. If you have good jokes, send them to me. Last thing I wanted to say just before I actually start really the presentation. In your bags that you receive from the conference, you have something called, we received the Always Thinking of You postcards from Fermentis. There is already a stamp on it, and it's for you to send to anyone you missed during the pandemic. On the back, you have also explanation. If you post the picture on Instagram, you might win a whole swag bag with a lot of Fermentis products and goodies. So please send them and just tell someone you've been missing them. All right, today what I wanted to talk about, there are kind of 3 chapters. The third one, just because I talk a lot and I feel like I'm already a bit late because of the technical issues. The third one, I might have to go very quickly on it, but what I want first is to introduce, fermentation. What do we know about fermentation? What does yeast do? The second one, we're going to use the basis from chapter 1 is really talk about the choice of yeast for beers, and the third one, choice of yeast for ciders. All right, the 3 dimension of fermentation and other yeast basics. So what do we know about fermentation? In 93, Graham in MBA Technical Quarterly published this drawing where he said, we know a lot about any process before fermentation, work preparation. In a case of, a juice, the processing of the juice of the grape juice or apple juice. We know a lot about the post-fermentation and how it affects, specifically the beverage, but fermentation was a black box, like question mark. What do we really know about fermentation? Not a lot. And I think in 2016, he reviewed his own publication where he said, in the past 30 years, a lot happens, and now it's not a black box anymore. It is a gray box, meaning we still don't know a lot, but we've done so much progress in understanding the impact of yeast on fermented beverages. So moving from there, and I'm stuck again. Oh, yeah. Oops. Don't know what to do. I have to stop sharing again. Sorry, everyone.
Take your time. We got it.
Don't really know what triggers the reason why it stops on some specific slides, if anyone has a clue. All right. So moving on from this, I have this gray box that is now not black but gray. And at Fermentis, we like to see fermentation as a three-dimensional world where really the first dimension is going to be really the yeast intrinsic characteristics, where it's if you have, you're fermenting with different yeast, the same wort, for example, of course, you don't expect the same thing from, let's say, a lager strain than from a Belgium strain in terms of kinetics, in terms of aromatic profile. So pretty much the phenotype of the yeast strain expressing very differently. The second one, like I said earlier, are going to be the impact of the fermentation parameters. So you take the same strain, you ferment it, at different temperature, different pitching rate, even different nutrient programs, then you're going to have definitely different beverages. But some strains, and we'll see that a bit later, definitely move way less and are very stable in all conditions. And at the opposite, you can push some strains really in one direction by playing with that. The last one is the interaction with raw materials, and I briefly show you some studies that we've done with mainly interruption of yeast and hops and what some people call the biotransformation. All right, the alcoholic fermentation, obviously we all know, transforms the sugar through sort of the fermentation into ethanol and carbon dioxide, and the yeast does that in order to produce energy to reproduce. Under the form of ATP. But of course, the yeast does way more than that. And this is just a very quick overview of what happens during the fermentation. So you have all these transporters for different type of sugars in the membrane of the yeast. You're going to have transporters that are transporting simple sugar like glucose or fructose. You can have transporters that are transporting the maltose, so 2 units of glucose, and some transporters that have affinity for both maltose and maltotriose, so maltotriose being 3 units of sugar. And depending on what transporters the yeast has, it has more or less affinity for these sugars. Once they're broken down into individual glucose units, they're being fermented from glucose to pyruvate, and from there, the pyruvate is glycolysis, and from there the pyruvate is fermented into ethanol and CO2 that is toxic to the yeast, and the yeast is then rejecting it in its environment. So what happens here is that, of course, there are a lot of reactions that are not shown here, and all the byproducts of this are going to produce what makes your beverage. Why does a beer taste like a beer? It's because the yeast is producing a group of molecules, the higher alcohol, the esters, organic acids, some sulfur compounds, some aldehydes, some fatty acids that are going really to give you a perception of the beer and flavor aromas. And of course, it would be too good if I could move to the next slide. I'm going to try to share a PDF instead to see if it helps. I have that ready, so let's see. I won't have any animation, but maybe that could help. Or maybe I should just try to share my entire screen.
That might help.
I'm going to try. Could be the animation, someone says. All right, can you see the presentation now?
Yes, we can.
Okay, I'm going to keep going and hopefully. All right, so let's talk about yeast and beer. From my perspective, you have 2 options. If you want to make a beer, you choose from a list of strains that are recommended for the style and that you are making, and you follow the recommendation of temperature, of pitching, and you see where that's going. It's way more interesting to really understand what are the aromatic profile and characteristics of the style you're making, and also what you are specifically trying to achieve for your beer. And based on that, make an informed choice looking at the yeast characteristic, and see which yeast fits the best the criteria. And after that, of course, also play with the fermentation parameters to multiply the possibilities of what you can do with this strain. So pretty much the more informed you are, the better you're going to be prepared to choose a yeast strain. So I think one of the most important things to understand is sugar utilization by the yeast and attenuation in order to choose the right strain. So this is the sugar profile in a typical wort during with a typical mashing profile. You're going to have, of course, a portion of the spent grain, and then a whole portion of what we call the non-fermentable extract that most yeast won't be able to ferment, with glucans, with proteins, with dextrins, and we'll talk specifically about dextrins and how some yeast can actually ferment dextrins. And then we have what's called the fermentable extract that is going to be mainly the maltose, 2 units of glucose, the maltotriose, 3 units of glucose, and sucrose, glucose, and fructose. So why is that important? Because the yeast is really going to use this sugar in a sequential order. So all yeast are going to start using the glucose. Here you can see the glucose. Once the glucose is down, it's going to start fermenting the fructose. Once the fructose arrives at a certain level, you're going to see that the maltose is going to start going down. And once again, once the maltose arrive at a certain level, you're going to see that the maltotriose, if it can ferment the maltotriose, is going to start going down, eventually to arrive at a certain level with residual maltotriose in that case. So here I have different cases, different scenario. This is a yeast strain that can assimilate and use the maltotriose very well. So you're going to see that you have the glucose being fermented, the fructose, F, G2, the maltose, then you have G3, the maltotriose that is eventually fermented very well with very little amount, and you have the dextrin here that stayed untouched by the yeast. Here, second case, you have a yeast that doesn't consume a lot of the maltotriose. So everything is the same, but look at the maltotriose here. You have a little bit that gets fermented, but a lot of it stays behind, and that's going to leave you really a very different perception of attenuation and of mouthfeel, of course. And then you have what we call diastatic strains. So what diastatic strains do, they produce an enzyme called the glucoamylase, and the glucoamylase is going, in the environment, is going to break down this complex sugar into more simple sugars that the yeast can ferment. So we see not only the maltose, the maltotriose, everything is fermented, but even the dextrins start being fermented with a diastatic strain. So when you choose a yeast strain, of course, you want to understand what this means. This is just coming from the Fermentis information. You have the South Ale, for example, range. So this is some of our yeast strain in the ale portfolio. You can see the information about how much maltotriose is left after fermentation. This is just the typical fermentation. And you can see that you have some yeast strain that leave a lot behind, like, for example, S33 is a very low attenuator, T58 too. And then you have some yeast strain at the opposite that are going to leave no maltotriose behind. Some of them are diastaticus, B134, WBO6, or 2 diastaticus strains. So that explains why there is no maltotriose behind. B256 is not diastaticus, but it is a maltotriose plus strain, so high attenuator. And then when you look, for example, typically in a lager range, you see way less diversity. And you can see it here in the 3 yeast strain that we carry at Fermentis. You have not a lot of diversity into the fermentation of the maltotriose. And I'm stuck here too. All right. Can you see something?
Not at the moment.
Oh, okay. It's very...
Although, by the way, we did have a comment from somebody earlier who loves your earrings.
Oh, well, thank you. I love citrus. Anything citrus, though. I am sharing my screen. All right. What can you see now?
We can see PowerPoint.
All right. Well, we're going to have to go through this like this. I really don't know how to fix it. Okay, so This is just a picture of residual sugar post-fermentation. And once again, you can see that you have the different sugar, glucose, maltose in yellow, then maltotriose in purple, then the dextrins here in these two colors. You can see that you have strains that are going to leave a lot behind, especially a lot of maltotriose, and strain, like this one, it's a Diastaticus, that are really going to ferment all these sugars. So that's kind of a proof of what I was saying earlier. So of course you want to understand how this before you choose a yeast strain, because this is going to impact a lot the attenuation of your beverage and of course the drinkability and profile of your beer overall. And that's the overall apparent attenuation, the ORS strains. So once again, you have the same conclusion. You have yeast strain like the B134. It's a diastatic strain. You can see high level of attenuation. Then you have, a maltotriose plus yeast strain with high attenuation, around 85%, and then some L strains with very low attenuation, in the range of 70%. And once again, the lager strains, very, very similar, what you can find in the market for lager strains. So diastatic strain, what are diastatic strains? They're Saccharomyces cerevisiae, var diastaticus, so they're part of the Saccharomyces cerevisiae species. They were isolated for the first time in 1952 for their ability to reduce the starch and the dextrin. And like I said, they produce this extra glucoamylase that is going to cleave the complex dextrin and sugars. For this reason, they're highly attenuating, and usually they contain one of these genes, STA1, STA2, STA3. I don't know if you heard about that, but not all yeast that have this gene are going to express it. Most of them, many widely yeast that you find in nature are going to be diastatic strain, but also a lot of commercial strains. And like I said, at Fermentis we have two, but most suppliers are going to have a few diastatic strains in their portfolio. There are usually Belgian strains, but not always. So, for example, BE256, it's a Belgian strain, but it's not a Diastaticus. And typically they are POF positive, and we'll talk about what POF positive means later, and high attenuating. So just of course, when you choose a diastatic strain, you have to know that there are risks associated with that. You want to make sure that if you have a contamination with a beer with a diastaticus, or if you bottle a beer where the fermentation is not completely over with a diastatic strain, you might have potential re-fermentation in bottle, and that's definitely some risk, a large safety risk of overcarbonation and of flavors. And I'm stuck. That's going to be.
And I think it looks like what's happening is when you interact with something outside of PowerPoint, that's when it loses the ability.
When I interact with something outside of PowerPoint, I'm not moving.
Yeah, when you went and moved that, hey, Crowdcast is sharing your screen. Mm-hmm. I think that may have been part of. I think that may be part of the issue. But
so when I move you mean the mouse on the screen?
No, that little notice down there at the bottom that says crowdcast.io is sharing your screen. Stop sharing.
When I move that one, when I move the thing, okay. Yep. Okay, I try not to move it. All right, and I'm gonna pass on that one, fortunately, because I feel I'm losing a little bit of time with these technical issues. All right, something else to consider when you choose a yeast strain is alcohol tolerance and resistance. Obviously, like I said earlier, ethanol is toxic to the yeast. That's the reason why it's producing it and rejecting it in the environment, because it's destabilizing its membrane and the key function of its membrane. But the amount of alcohol that each strain can handle is really strain specific, and there are also other factors that define the limit. Usually it's a combination of high temperature, low nutrient, presence of other toxin with the alcohol. Of course, that's something you want to consider for high gravity beers. When you select a yeast strain for high gravity beer, you want to make sure that you select something that can handle, this amount of alcohol. So typically, for example, B256, we know it's a yeast strain that we recommend for high gravity beer because it can handle that high alcohol. And for example, HA18 goes to 18% alcohol. It's a blend with an enzyme, and that's also something, if you want to do these high gravity beers, that could be a good option. All right, kinetics. Obviously, I know it's not always a criteria of choice, but you need to be aware that, when you choose a yeast strain, you're going to have different kinetics. Here you have just an overview of different beer in yeast strain in the SAF Ale portfolio. And you can see that there is a wide variability, not only in the lag phase time, which is, the time the yeast until the yeast really, you're going to start seeing the beginning of the fermentation. So, for example, typically SAF Ale USO5, it's a very popular option, but it has a very long lag phase. And you also see a lot of variability in the fermentation rate. And here you can also see the overall attenuation is very different between the strains. You can see it here on the graph. There is also a high impact of gravity and temperature on these kinetics for sure. And the more studies we do, the more we see that temperature is usually the biggest driver in fermentation time. All right, SAF lager. So this is the same thing. You have kind of the fermentation profile of our lager strains. And you can see that you see less differences overall. Every time we talk about lager strain, you're going to see that you see way less differences between lager strains that you do see between ale strains. All right, flocculation and sedimentation. So I think there is kind of a misunderstanding that sometimes these two things are the same. But they're not. They're very often linked, but they're not the same thing. So flocculation is an aggregation of the yeast cell into multicellular masses called the flocks. So here you can see a non-flocculant versus a flocculant strains. It is due to the genetic trait of the yeast, and it is very strain dependent. But of course, there are also external factors such as the temperature, the cation present, the pH, a lot of things that can influence whether a yeast flocculates or not. So what happens here, you can see that the yeast cell has some flow protein at its surface, and the calcium cations are activating these proteins and make them active. And when they are active, the yeast cells can flock together. We do recommend a certain amount of calcium at Fermentis for good flocculation of your yeast. And if you have any question on that, feel free to reach out. There are two different, in ale yeast, you have usually a greater hydrophobicity, which cause them usually to potentially associate, the flocks can associate and have a great affinity for the CO2, causing the flocks to really rise to the beer surface. And that's what you have during the traditional top cropping ale fermentations. But in many modern breweries, ale strains have sink to the bottom of the CCV's tanks, and that's how the mutants have progressively been selected, and pretty much selecting the ones that were, easily bottom cropping. So kind of two different groups of ale strains there. For the lager yeast, the Saccharomyces pastörianus, they tend to be less hydrophobic, which means they don't have usually that good affinity for the CO2. So there has been a shorter but very strong history of selection, and the ones that have been selected really sink to the bottom pretty easily. So once again, we go back to the SAF Ale and SAF lager range from Fermentis, where you see here the characteristic of the flocculation, whether it is or not a flocculant yeast. And then you have whether it's going to do a clarification, meaning going up with a good affinity with the CO2 and end up in a foam, or if it's going to sediment. And what you can see here is that you have yeast that are good flocculators and that are going to have a good sedimentation. SO4 is, a popular option for that. But then you're going to have yeast strain that are the opposite. They're good flocculator, but they have a high affinity for SO2, so they're going to have a good clarification in the foam. And at the opposite, you have some strains that are poor at flocculating, and usually they are or ending up in clarification or just very slow sedimenters. Once again, the Lassa Lager range, you can see that they are more uniform and tend to sediment pretty fast. So that's definitely something to consider when you choose a yeast strain. When you choose a yeast strain for bottle re-fermentation, what you are looking for, usually it's a yeast strain that is going to be powdery. Here you can see this is a powdery strain. This is a more flocculating strain, and you can see this create little flakes when you resuspend it in your beer, versus a powdery strain that aesthetically is also more pleasing. All right, yeast flavor and aromas. I'm not going to go through this slide. The reason why I wanted to put this slide is to show you. So these are all the fermentative flavors and, volatile compounds that are released from the raw material, from the hops, for example. What I wanted to show you is this is just a small portion and simplified of all the reaction that happen within the yeast. And all these reactions, are catalyzed by enzymes, and they are highly regulated by the genetic of the yeast, by the condition, the temperature, the nutrients. So the environment and the yeast strain that you select are really going to give a completely different profile of all these molecules, whether they're positive, like the esters, or negative, like the acetaldehyde, associated with this oxidized apple or the fatty acids, giving a completely different profile for each strain. So this is an example, once again, with the Fermentis portfolio, where you see some yeast strain in the ale portfolio are going to have very neutral profile, like the USO5 or the SO4, which makes them very versatile in styles because they're more neutral. And then you have some yeast strain that are going to be on the opposite of the spectrum, like the WBO6 with a lot of isoamyl acetate in the ratio, the B256, and they're going to give you very specific profile. This one has a very strong Belgium ale profile. T58 also, WBO6 is our good option for effervescence. So definitely stronger aromatic profile. And you can see that once again, the lager strains tend to be very neutral in aromas. So whether you're looking for a yeast strain that is going to be versatile, that's going to be pretty neutral, like USO5, SO4, K97, where you can really multiply them with the styles. All right, POF positive. What does it mean? POF positive means phenolic off flavor. So it's the expression of a gene. The POF positive strain have a specific enzyme that is going to decarboxylate the phenolic acids from the beer wort, such as the ferulic acid or the cinnamic acid, into respectively compounds like the 4-VG or the styrene from the ferulic acid and cinnamic acid. And this is going to give you these spicy, clove, medicinal flavor characteristics of certain styles of beers. And of course, it's also depending on the concentration of the ferulic acid in your wort. But the choice of yeast here is going to be key in order to develop these compounds. It's definitely a good choice for some Belgian ales and wheat beers types of beers, but it can be extremely undesirable for other types of such as Pilsen beers, stout beers, and a lot of our studies have showed a negatively impact of POF positive strain on the hops perception. So if you have, styles where you really want the hop to shine, the fact that you have a POF positive strain can really hide the hop characteristics. And so usually these two don't mix well together. All right, so how to make your choice? So I think, of course, you can go by the name and say, oh, this one is, a good Abbey strain. This one is a good Saison strain, whether you're trying to make a Belgian style or effervescent strain, wheat strain, whatever. But the way I present at Fermentis, we like to, first of all, keep names of the strains that are that do not associate them with a style, because really you don't want to put a yeast in a box. So the way we present our strain is going to be this little make your choice graph where you have kind of three circles. The axis here that is going to be the fruitiness going up in this direction. And this is linked mainly to the amount of esters that the yeast is going to produce. An axis that is going to be the spiciness. So that's whether the yeast have some POF positive characteristics. So you have WBS6, 134, T58 that are, in that category, or whether they're more neutral strain where, they're going to be really helping you to put the emphasis on the raw aromas in your beer. So, if you're looking for, any type of beer that you're doing and you're looking for, a more neutral strain, ale strain, you're going to see that USO5, K97, SO4 are good choices. And then if you're looking for some strong fruity profile, B256, S33 are good options. And if you're looking, for specifically POF positive strain, B134 is a good balance between a fruity and spicy, and it really fits well for example, the saison style. WBO6 would be in that area of the graph too. So fitting well the Hefeweizen style, for example. T58 is going to be a very specific type of spiciness with a lot of black pepper. So it could be associated to a lot of Belgian styles too, or it could also be used in co-inoculation. But you can see that it's kind of guides you toward a choice of a strain without really putting a strain in one specific style. All right. Dimension 2. We talked about the first dimension, the intrinsic characteristic of the strain. Now, if you take one specific strain, let's say here, I go back to this graph, how do the fermentation parameters affect strains in this global picture? So we took, for example, we do every year at Fermentis studies on different strains in our portfolio. And here I just chose, the main conclusion of two studies we did because they're very different yeast. The B256, that is a strong Belgium fruity profile strain versus W3470, that our Saftlager Weinstefan strain, that is the most, very neutral lager strain. And what we did is we used the strain and we fermented in different temperature conditions with different pitching rates and at different initial gravity. And I don't have the time, unfortunately, to show you all the results, but if you're interested, you can look at our webinars. We have all of that out there. And these are the main conclusion, and they were complete opposite conclusions. Saftlager W3470 is a neutral strain. And whatever we were doing, increasing the pitching rate, lowering the pitching rate, the gravity, higher temperature, it stayed very neutral. So it was very robust and stable over many different conditions. And so a lot of people post this study started fermenting with this strain at higher temperature and noticing that they could still produce a lager that was, very neutral and, really like speeding up the fermentation temperature. So that was pretty much showing that for this strain, fermentation parameters don't seem to actually be that important in the final profile of your beer. At the opposite, for the Safel B256, it was very interesting to see that the biggest driver for this strain were the high gravity and the temperature. So really, it was really a good fit for styles of beer where you would like high gravity Belgium styles, or also at a certain temperature was definitely the most interesting and stronger fruity profiles. And at the opposite, this kind of study, for example, helped us notice sometimes people said with this strain that they had sulfury notes, and we couldn't really figure out initially, what was the driver, and actually realized that when you overpitch this yeast at lower gravity, you could have sulfur notes, and that kind of helped us now guide people, to avoid also some default. Okay, so that was just an example. Obviously, I don't have a lot of time to go through everything. I just want to kind of, show you a little bit of everything. So dimension 3, it's, remember, the interaction of yeast and hops. And I just want to show you once again an example of a study we've done, and you can see way more in our webinars, where the idea here is that we are fixing the fermentation parameters, initial gravity, temperature, pitching rate, and we did many studies where we looked at the interaction of our strain with different type of hops, addition of hops at different time, and also just screening our yeast on different hoppy styles of beers. So, we took one style with many styles with one specific recipe and screened all of our yeast. And we have a few of these also. Once again, in our webinars, you can find a lot of these studies fully displayed. But this, for example, this study comes from the New England IPA study we did in 2019. We presented these results where we had, a recipe of New England IPA, and we screened all our yeast both on a volatile and sensory analysis profile, looking at what strain really fit the best style, and that led to kind of some recommendation of what yeast really had the most interesting interaction with hops. And we highlighted, for example, these 3 strains, the SAFL SO4, S33, K97, that were good choices, both for the aromatic profile, for the juiciness, everything that you're looking for this style of beer, pretty much. And, we identified, for example, that K97 had more that green hop characteristics, when SO4 had more like a peat fruit type of hop aromas, and S33 was really the one with the most tropical fruit. So it was this type of study that really shows us how much the yeast interact with the hops in specific styles and give us ideas of recommendations. So, of course, I say don't just follow someone's advice on recommendation. Of course, you always want to hear, from these studies. But I just want to show you when we recommend styles, for example, yeast for hazy IPAs, brut IPAs, we usually have studies behind that shows why we recommend this yeast for this style. And feel free to reach out if you want more information. In our tips and tricks, it's on our website. You do see recommendation of some strain for specific style, but the idea is that you don't wanna just put this yeast in this box. You can do many styles of beers with many types of yeast, and we definitely don't want to put a yeast in a box. I think you received this in your goodie bag. I just wanted to say it now here. This mini poster, I think, was included with the postcard. So that might give you kind of a rough idea or so of each yeast strain from the Fermentis portfolio. All right, how late am I? I'm gonna have 5 minutes to talk about cider, right?
Don't worry, we have plenty of time. So if you want to take a little time.
All right, sounds good. All right, so I talked about yeast and beer. Now, yeast and cider is a whole different picture, of course, because there are other considerations to take for ciders. There are many type of ciders and related substrate. The first difference is going to be what type of juice or apples you're using. Are we talking about sweet, bitter sharp varietals of apples? All the bitter varietals are going to have more tannins. The sweet ones tend to have less acid, the sharp one more acid. So they're all going to have different ratio to tannin and acid, and that is going to impact eventually your fermentation and what type of yeast you're going to want to choose. From there, you usually go to a fresh apple juice. That's going to be approximately 15 brix. One of the biggest thing to consider with cider is going to have a high amount of fructose. Compared to other fruits, up to 70%, which is huge. And this is pretty much going to be important because a lot of yeast strains don't have a high affinity for fructose, so leave a lot of fructose behind. So whether you're trying to make a dry cider, you really want to make sure that you're selecting a yeast strain that is going to be, we call them fructophilic. So from there, you can make different type of cider. You can make a sweet cider, which is very typical in France, for example, where you stop the fermentation at 5% ABV. And this is fermented at very low temperature. And I've noticed it's more and more popular in the US. I hear more and more cideries, doing fermentation at low temperature in this style. Or you can make a dry cider, which is usually done at medium temperature. And here, obviously, you try to ferment it dry. The other option, of course, from a fresh apple juice is to produce apple concentrate up to 70% Brix, which is commonly used for, industrial, but also people making cider at home. And something that's important to consider from there is that apple juice concentrate are very low in nutrients, so it's definitely something to consider that you're going to need to provide nutrients if you use apple juice concentrate. And so you can use them and dilute them and add sugar potentially to make high gravity cider up to 18%. And here, the real challenges for the yeast are going to be to handle this amount of ethanol, but also to handle a higher temperature, because these tend to be fermented at higher temperature. So that's just a global vision of what cider means. And you can see that it's once again, it's just like beer. You have many styles, and it's not one yeast fits all types of cider. So what criteria for yeast collection? If you are making a traditional sweet cider production, I think something to consider is you want to select a yeast that can resist to low temperature, because usually you ferment between 8 and 15 Celsius for this cider, and not all yeast can handle that low of a temperature. You want to make sure that you also select a yeast strain that has that is SO2 resistant. A lot of the juice that you might buy, or you might use SO2 in the process, in the juice processing. So not all yeast can handle the same amount of SO2. Some yeast can be completely inhibited, as low as 50 ppm of yeast, so of SO2. So it's important to consider. Then if you are making a dry or high gravity cider, I think what's important is to know that usually you have up to 70% fructose, and you try to ferment a bit further than in sweet cider. So you really want to select a yeast that is fructophilic, because really the fructose is the last part of the sugar that's left behind. And if your yeast is not fructophilic enough, it's going to stop fermenting and leave a lot of this fructose behind. That is actually, the fructose has a stronger sweetening power than the glucose. You also want to select a yeast that has low nitrogen requirement, because once again, you're going to try to ferment more sugar and you have low nitrogen. So it's always better to choose a yeast that doesn't need a lot of addition of DAP or yeast derivative to ferment. And finally, you want a yeast strain that can handle high ABV, especially if you go high gravity, and low pH resistance, because the higher you go in gravity, the more the yeast should be able to handle the change in pH. All right. For all type of cider, you want a yeast that produces low amount of SO2. I think it's something that every cider producer is looking for. You want a yeast that produces low amount of sulfur compounds production. That's going to give you these rotten eggs, cabbage type of aromas. And you want a yeast that produces low amount of acetic acid and volatile acidity overall. That is a nail polish remover, vinegar type of aromas. And of course, on the positive note, you want a yeast strain that has the positive aromatic profile that you're looking for. So looking at fermentation kinetics, ABV, and residual sugar, it's important to know that that all strains have different fermentation behaviors, and that can make them suitable or not for different cider styles. So I'm just going to give you here an example. We have 4 strains in our staff cider portfolio: TF6, AC4, AS2, AB1. For example, you can see that TF6 is not really suitable for dry cider. All the other ones are, so that's definitely something to look at. The reason is because it's not very fructophilic, and also it cannot handle It needs a lot of nutrients. So lots of factors that makes this yeast not suitable for dry cider. So you want to look at that. You want to look at the sulfite sensitivity. If you're using sulfite, you want to look at the fermentation temperature. You can see that this one does not handle low temperature. And fructose assimilation, like I said, is a big thing if you're trying to make a dry cider. You want to look at the analytical and aromatic profile of each strain. Just like the beers, each strain is going to have their own aromatic compounds baseline, as they're going to produce more acetate esters, more ethyl esters ratio. The ethyl esters giving you more this complex fruit, the acetate ester giving you more this candy, strawberry, banana candy, intense aromas. So here, for example, you can see TF6 is going to produce a lot of acetate esters, these strong banana flavors, when really AC4 is going to produce a lot of the ethyl esters, tend to bring a more complex type of fruit profile to your cider. Something else to know that I think not a lot of people know is that yeast have the ability to consume malic acid. There is a lot of malic acid in cider, in apples. So you can see that, for example, AC4 is not going to consume a lot of the malic acid, when TF6 or AB1 is going to consume a lot. It's going to do, it's going to reduce the acidity and the crispness of your cider. So if you want to keep a really crisp cider, you're going to want to select a strain that has low consumption of malic acid. And finally, you also want to look overall at the volatile acidity, the production of SO2, of acetaldehyde, all the things that you want to keep at a minimum to have a clean cider. So always important to look at. So of course, you're going to choose a strain, like I said, on the overall sensory profile. It's very important. Just like for beer, we have this kind of simplify, make your choice drawing to help people guide them toward the choice of yeast. So it's pretty simple to read. So you have our 4 strains here that have each of them a different color, and you have different axes. You have whether the mouthfeel, whether the strain is going to give you a sweet mouthfeel. And that was going to be, for example, TF6. TF6 is going to leave a lot of the fructose behind, AS2, a little bit of fructose too. So it's going to give this sweet mouthfeel, even at the same level of residual sugar. And then you're going to have AB1 and AC4. That AB1 is going to be very balanced, and AC4 is really keep you this malic acid that's giving you a crisp mouthfeel. And then you have the type of aromas that the strain is going to produce, and that's based on sensory analysis. So whether it's going to give you some fresh type of aromas or more cooked, jammy type of aromas. So you have, for example, AS2 that's going to be more balanced between cooked and fresh, and at the opposite, AC4 that's going to give you this strong fresh profile on your cider. So we give all of this information. There is way more detail here also in the type of aromas that they're producing, the type of mouthfeel, sweetness, crispness, and I think we provide a lot of information. But of course, if you look on the market of yeast for cider, you can find all this information for each strain if you're looking for it. And I tried to speed up a little on cider. I just didn't want to push too much. But that's it for my presentation. I wanted to say one more thing. We have 2 winners. We had a yeast giveaway. 2 names were selected. So Renata Simmons in Fort Lauderdale in the US, and Hayley Friedland, I'm sorry if I mispronounce your name, in Seattle. And I have your email address, and I will contact you to know what sample you'd like to receive.
Well, isn't it always good to end on a high note with free stuff?
Yeah, and also here's my email address, so feel free to write it down if you ever have any question about Fermentis product.
Right. And of course, this presentation will be available on the Queen of Beer website, so people will be able to come back and actually view it. Don't forget, we're going to break into some questions now. So go if you haven't asked a question, go and ask a question at the Ask a Question button. And meanwhile, Anne, are you ready to play 20 questions?
20 questions, sure.
All right. So the very first question, actually, right now we have 5, but the very first question is from Deborah. I am interested in brewing ultra low ABV beers and gluten-free beers. Are there better yeast strains for these types of beers? Are supplemental yeast nutrients recommended for brews that have low or alternate types of sugars?
Yes. Sorry. So the beginning of the question was low ABV.
Yep.
Sorry. So there were multiple questions in the question.
Right. So ultra low ABV.
Yeah.
And gluten-free. Do you have better strains?
So first of all, if you need to ask your producer if they're producing their yeast on a gluten-free substrate. So not all producers have gluten-free yeast. I know we do have, our yeast are certified gluten-free, so that means less than a certain amount of gluten. But you need to ask your yeast supplier. That's number one if you're looking for that. And that's pretty much it on the side of gluten-free in choice of yeast. Low ABV, I think there are different options out there. For example, so if you're looking to do really low alcohol, we do have an option that is maltose negative. So remember, a big part of the fermentable sugar are maltose. So if you're looking to do a truly low ABV, 0.5%, I'm just putting it out there, it's becoming a trend. We have an option for you, and it's a maltose negative strain. So if you're interested, it's called SAFL LA01. You can look into that. Other than that, if you're looking for low ABV, there are many yeast strains that you could select in our portfolio, in the L portfolio. If you're looking for low ABV and also low carb, meaning leaving less sugar behind, it's interesting for you also to select blends of yeast and you can all use an enzyme, or you can select, we also have some products that are blends of enzymes and yeast. So the enzyme is going to break down all the sugar and make them all fermentable. So you're going to have really a high level of attenuation with this product.
All right, and then the follow-up part of that question was, are there supplemental yeast nutrients recommended for brews that have low or alternate types of sugar?
So for sure, if you use a high adjunct in your brewing process, so that's going to be simple sugars not bringing any nutrients. You might have low amount of nitrogen, too low for your yeast to be able to ferment the amount of sugar that it needs. So we do have nutrients at Fermentis. So we have, for example, for brewer, we have a product called Spring Ferm BR2 that provides it's inactivated yeast. So it's going to provide a little bit of organic nitrogen. It's going to provide zinc and other things that you're going to need. We also have a portfolio from winemakers that are richer in nitrogen that you could use. So yes, I would say that there are a lot of products out there to use. We have one at Fermentis called Spring Ferm BR2 that we recommend for high adjunct brewing.
All right, great. All right, next question it comes from Leah. It says, oh, wait, sorry, it got jumped. Sorry, we'll get back there. We got a question here. Are some of the charts available on the Fermentis website? I know we already said the presentation will be available to everybody, but
that's something that I wanted to say too, and actually thank you for saying that. So on our website, you have a lot of things. You do have a little, if you go to a category called tips and tricks, you have, it's a little book. It's actually very nice. This is not the last version. That's a version before that I had on my desk. But inside you have a lot of the graph that I have in my presentation about the intrinsic characteristic of our strains that's in there. And it also explains how to use active dry yeast. So, and yeast in general. So that's a good resource. And something that I know a lot of people really like, we have an app, a free app. It's called the Fermentis app. That's what you type. And in there you have, first of all, you have a lot of calculators and stuff like that. But also, if you use Fermentis yeast a lot, it gives you all the information about, about the attenuation to expect with each strain, if you enter a few information. So you have a lot of information out there. And like I said, if you go to events or to our YouTube, go directly to our YouTube page on Fermentis. We have a lot of webinars. Also, if you want to rehear, I just try to give a little bit of everything, but really on each topic, I could have talked for an hour. And for example, yeast and hops, we probably have 10 or 15 webinars out there just talking about, different styles and different studies. So yeah, different places to look for information. You're on mute.
Oh, I'm sorry. Yeah, so start at the website and go from there.
Yeah.
Lots of information available.
Yeah.
By the way, that one slide that you showed with the different produced flavors during the cycle, that was definitely one of those ones where it was like, oh, that's why this has been a gray box. Particularly when you said that's the simplified version.
It's actually one of my favorite slides. I actually love to spend 10 minutes of that slides. I know not everyone does, so I usually don't, unless it's a highly technical presentation. But here the idea was to give an overview, so we couldn't really go deep in anything. I just wanted to give an overview of how yeast impact fermentation and the different aspects that are going to make you choose one yeast versus another for
Absolutely. Well, and there will be plenty of time for people to dig into more information. All right. So next question is from Leah, who says, I direct pitch dry yeast often. A quick question. How does storing my dry yeast in the deep freeze affect yeast negatively? I also keep agar plates frozen and just pitch that into starter on a stir plate.
So you freeze the yeast once it's open, or you freeze the yeast before it's open? Because I didn't understand that part of the question.
Right. You can either drop a comment in the chat or.
Yeah. So when active dry yeast is dried, you have no freestanding water, which means that freezing active dry yeast is not going to affect it. You can freeze it and take it out of the freezer. I'm thinking about the 500 gram. I know, a lot of you might use the one that is not under vacuum, but so you technically can freeze. The problem is when you start opening a package, and then you have humidity going in, because that's what happens when you open a package, and then you freeze it. Then the yeast has absorbed some humidity, and then the freezing process might hurt the yeast because you're not in that no freestanding water, and then you have crystals of water that could hurt the yeast. So as long as an open package, you're kind of fine freezing it. If for some reason you're using some large package and you want to, use it in different batches, and we recommend using it when it's open, but I know some people might want to do differently. We do recommend that you remove as much of the oxygen, and so pretty much if you can repackage under vacuum to remove as much air and humidity out there, it's better. And I think then the best is to keep it in the fridge, not in the
right. All right. Yeah. And Beth is following up in the
Beth, sorry, I'm answering Beth's question.
Yeah. Yeah. So next question that came up actually also from Beth. Any Flock FLOC versus Flock FOLCK yeast jokes?
Do I have Flock's jokes? No, I don't. But if you have some, send them to me.
There you go. Help Ann out. She needs more jokes. All right. And then we had a question here. What is the upper limit for 3470 before the flavor was affected? I'm assuming upper limit for temperature, or
we went up to 24 Celsius. Sorry, I'm really bad with conversion. So ale temperature, pretty much. And even there, it stayed super neutral. So that doesn't mean we recommend people fermenting all the way to 28 Celsius. That's not what we mean. But we definitely saw no impact of neutrality as hot as 25 Celsius.
Right. And I can speak from professional experience around here in LA. I know that some people have been using 3470 to make IPAs very clean and doing those at traditional ale temperatures. So, okay.
And you could definitely, so something else, so the big pros, the reason why people, want to ferment at a higher temperature at a professional level is because they want to have a quicker turnover in their tank. The main problem of fermenting at low temperatures might take weeks to ferment, when here we saw no impact on flavor and fermentation shorter by 2, 3, or 4 times.
Right. Well, and I will also give a shout out to 3470 for being the global workhorse. I think in the last year, almost every Pilsner I've had or lager beer that I've had from the LA area has been made with 3470. So, all right. Last question that we've had asked so far. I like to co-pitch liquid yeast to get the best of both strains. Mm-hmm. Am I able to do the same with dry yeast?
Absolutely. And I would even say that I think it's easier with dry yeast, just because if you're aware of how to use dry yeast, it's really, if you use fresh yeast every time, which I think is very easy to do with the value of the product, you use it by weight. So you just have to measure the weight of the yeast strain, and that's it. So if you want to co-ferment, it's very easy to, instead of counting the cells, which really in liquid yeast, that's what you have to do. If you want to keep the same ratio of each strain, you have to know how many cells of each. For us, because it's active dry yeast and it's a very standard, it's going to be always the same amount of yeast cell per gram of product, you're going to have a very consistent mix ratio of the 2 yeast of active dry yeast. So absolutely, you can do that. We have a lot of people that co-inoculate P58 with other strains because it's such a strong phenolic strain, and it's a strain that grows faster than other strains. So usually we tend to say, if you want to use P58, use a very slow ratio, like 10%, and then co-inoculate with S33, for example. And the aromatic profile goes a long way. So absolutely, and I would say it's easier with active dry yeast.
Right. And I think for a while you guys were when BE234 first launched to homebrewers, there was a lot of advice from y'all to blend that with T58 as well. So
yeah, but yeah, I can see that. Yeah, and we also hear what's being done, by the brewers, and a lot of the ideas and things that we recommend is because a brewer tried it and he thought, oh, that's great. And then more brewers started doing that. So I would say most of our recommendation of blends come from the market. That's something that, we're interested into doing more studies, but really at this point, most comes from the market.
There you go. And the last question that's been asked so far, did you mention that you have training videos on your website? You did.
So I do believe that if you go to news, so you go to our website, there is a section called news and events, and you go to events. First of all, you're going to see all the webinars that you can register for free. If you want to go live and listen to a webinar and be able to ask questions. We do have some that are dedicated to homebrewers, some that are, most of them, all of them you can access, but some are really dedicated to homebrewers. And I know we have, for example, Q&A for homebrewers where we try to pick a topic and then, answer questions. So this one is always a good one. But then if you want to see the previous ones, the previous webinars are posted on our YouTube channel. And then you go to YouTube, Fermentis, and then you have all of them by title of the webinar.
All right. Well, there we go. That was the last of the questions that have been asked and voted through. Give it one last second for anybody who has any last additional questions to pick Anne's brain. Going once.
Sorry for the technical issues. I feel like I was trying to rush for no reason afterwards, but yeah, thank you for your patience, everyone.
No worries. And like I said, it is not a webinar until there's at least one technical goof up. Beth is asking, can you put your email address back up or put it in the chat, I think.
I will write it right now. Yeah.
Because I get the feeling that you have lots of yeast knowledge and lots of things that you can answer for people and lots of passion to do it.
Yes, for sure. Yeah. I'm very happy to answer anyone's question. Feel free to reach out.
All right. Well, everybody, I think that's the end of our seminar. So, and thank you so much.
Thank you very much.
Thank you for persevering. And in the meanwhile, everybody, there's still more stuff to be done, more questions. And of course, like I said, this presentation will be posted along with the video. So you'll be able to come back and revisit and try and soak in some more of the knowledge that was passed at you. Okay.
Thank
you.
All right.
Peace, everybody. Have a good Sunday.
Have a good Sunday.